Today's presenters, Thomas Diesler. And so Thomas is specifically the OSGi Project Lead at JBoss. So he's been working on OSGi now for quite some time, and he's been around Red Hat for as long as I can remember, a lot longer than I have. So Thomas and I first ran into each other 5+ years ago. He specifically worked on our web services capability for a long time, and he's been a key contributor to the app server for 6-7 years now, I believe, maybe longer. So Thomas is really an expert when it comes to understanding JBoss, and so we're very lucky to have him here today to talk about OSGi and how it's implemented. David has been very much focused on OSGi. He's part of the expert group, and he specifically worked with Iona Technologies and Progress Software. He's from Ireland. So Thomas, I should say, is from Germany, and David is from Ireland, so we're lucky to have them on the line. And at this point, Thomas, why don't you take it away?
Thanks, Bob. So good morning, good afternoon, good evening, depending where you are. Let's jump right into the deep end of OSGi, and I'll tell you a little bit what OSGi is about, the OSGi core technology, before we move on to Enterprise OSGi and later OSGi specifically applicable to our latest application server, the AS7. And then at the end, we have a little demo, and then we do Q&A. So OSGi very basically is about modularity, services, and there's a security layer as well, which I won't talk about. So let's focus on modularity first. You're all familiar with Java packaging model, the jar file, and typically what you do is you put the jar files on some sort of class path. Implicitly, they are ordered on this class path, and classes coming or packages coming earlier in the class path will shadow packages that come later in the class path from the same jar with a different version, for example. So this is a problem you have on large scale system. When you're only dealing with 3 or 4 jar files, then you won't have this problem. How does OSGi solve this? It solves it in a way that it computes a class loader delegation path. So what it does, the jar file is now called an OSGi bundle. It provides capabilities, and it can have requirements. Capabilities can be package capabilities or package. You can have package requirements. So there is a non-trivial OSGi resolver involved. That when you install, the terminology is install. When you install all the OSGi bundles in the OSGi runtime, the OSGi resolver kicks off, calculates the wiring between the various bundles, and makes sure it comes up with a consistent class loading graph. So that means that the packages one bundle imports is provided by a package another bundle exports. It can also be provided by the same bundle. In an OSGi runtime, you can dynamically install, bundles have lifecycle. I should mention that. Bundles have lifecycle, which is different to ordinary jar files. So you can install, start, stop, uninstall a bundle. But you can also update a bundle. So that means that of the number of bundles you have installed in your runtime, you discover a bug, and at runtime, without taking the entire system down, you can update those particular bits that you want to update and fix. You can have side-by-side versioning of the packages. So you can have your, a third-party jar can be provided in several versions in your runtime, which I come to a little bit later why this should be or could be necessary. Another feature is that you have truly, private packages, which is not necessarily the case by the Java language on its own. Because as you remember, in Java language, you have public packages, you have package protected, and you have private packages. However, not every public package that you have in your jar file, you really want to be used from third-party clients. So what you do in an OSGi bundle, you can structure your software the way you like. You put your stuff in different packages. They need to be public by definition. But in your OSGi manifest, you only say, I want these two, for example, these two packages to world, and everything else is private to this bundle. I can change it anytime, even though the package is public. So we have no more Java, no more jar hell, which is also called. And the good news is an OSGi bundle can also be used as an ordinary jar file. If you run, in a runtime that does not support OSGi. The distinguishing part between jar file and an OSGi bundle is really the metadata that you put in the manifest, and we will see this a little later as well. Another key feature of OSGi, are its services. The OSGi runtime has built-in service support. So what happens is when you install the bundle and the bundle gets started, what will typically happen is that this bundle registers a number of services with the OSGi runtime. Services are registered by type. So you say this is a Java type, so typically this would be the fully qualified name of the interface, and you can have additional metadata provided with the service. So here we have a nice example which says it's a payment service and the location should be US. So a client of the service can use a lookup mechanism and say, I want an implementation that implements org acme payment, and then there may be several of those implementations available in the runtime, but the client specifically asks, I want a payment service that works for location US. Or you could say, I want a persistent service that is provided by JBoss, or I want service foo, but I need it to be secure, right? So additional to that, OSGi services are highly dynamic, so they can come and go anytime, and clients can react to this. So imagine a system where, let's continue to talk about this payment service. You have a runtime where a payment service is available that talks to Visa, for example, and your OSGi application can deal with that and provide some payment mechanism via this payment service to charge Visa cards. And then another OSGi bundle comes along which provides payment through PayPal or, MasterCard, for example. And then your application can react in such a way that as soon as the service becomes available, it can react to it, it can display the menu item, and you can now deliver payments through those channels as well. If something gets broken with these payment services, you take it off the OSGi runtime, the service disappears, and the client reacts to it and no longer make this functionality available. And as a consequence of this, I might have to say, as a consequence of this, you need to rate your application to keep, to design for this type of dynamicity, which is different in most programming models, but it is actually a huge advantage if you do so. Right, going to the next slide. Here I have drawn, this is actually a chart from Graham Charters from IBM, who I had the pleasure to attend a talk to some IBM folks. And he is very much involved in OSGi for IBM. IBM is using OSGi for a whole bunch of stuff. I don't know how many products they have, but OSGi is right at the core of their business. So what the industry has learned over time is software goes through a life cycle of designing, developing, testing, deploying, and then you deprecate the functionality, and sometime later it's end of life. So this is not only true for applications, which is very often seen as, but we are talking about, conceptually, we are talking about a module which provides a certain functionality through services, and this functionality, gets designed, developed, tested, and so on. And so we call this We call this module or bundle, and now we start thinking about the life cycle of this individual piece of functionality in a larger system. Again, a payment service could be applicable here. Yeah. So we start thinking about, what are the boundaries of my what are the logical boundaries of my functionality? Those boundaries I want to respect, I want to test, I want to well define those boundaries, and that piece of functionality then goes through its life cycle. Yeah, so and you appreciate the independence of these various modules, and well-defined public interfaces makes it easy to maintain that functionality, changing it without breaking clients. Because it makes a huge difference if you have, say, if you're in your exported package, you have two interfaces, and those two interfaces define your service interfaces. But the implementation of which, boils down to providing 200, 300 classes and so on, and it's very complex. Then going through the life cycle of that functionality is much more easier to maintain stability in those well-defined customer-facing interfaces, and everything else is, private to your bundle. So OSGi is not the greatest thing since sliced bread, as Mark Little used to say, but it is the de facto standard to solve the Java modularity issue, right? So the problems with modularity, they existed before OSGi. OSGi is now on the rise, being applied in very different areas, and I might talk a little bit about those areas as well. But even when OSGi goes away, the problems associated with modularity and module lifecycle, they won't go away. These are as old as the industry itself. Next slide. OSGi is not for free, right? So getting into the OSGi development model, you have to start thinking with modularity in your mind. You have to start thinking with dynamicity in your mind. You have to deploy your bundles to an OSGi runtime, and you have to deal with bugs of class not found or whatever cannot resolve this particular bundle, which you would not have in a bowl of mud type of scenario, which you usually have on a flat class path. So, there is an initial cost, and it will take you a little longer to get stuff established. However, when you think about modularity explicitly, you come up with a solution which is much, much better maintainable when your system grows, right? And you see OSGi is the green line. So as complexity grows, cost will scale linearly. Whereas if you don't design for modularity, then as complexity grows, you have in your system, you have 100, 200 jars. You don't know what packages are in there anymore. You have several disconnected teams working on the product, and they create dependency on third-party jars that you do not control anymore, and it's difficult to sync up. So when it finally comes together, bringing up or rolling out the product, it will be very difficult to resolve those conflicts which arise through not respecting modularity. The perfect example is the Eclipse platform itself. So Eclipse has the notion, Eclipse is built on OSGi, and Eclipse has the notion of plugin. So what you do in Eclipse, you go through, install feature foo, and there's a drop-down box, and you can say, I want feature foo, and feature foo boils down to, 20 bundles or so, which get installed into the OSGi platform. The providers of feature foo do not know what other features are already installed in your particular version, in your particular installation of Eclipse. Neither do they need to know. What they need to know is, or what they need to define is what requirements they have on packages or other, functionality being available in the Eclipse platform. And what they also define is what capability feature foo provides. So what now becomes possible is that you go to this drop-down box and say feature foo, and there is a repository which knows all about the bundles that are available. You do not need to know about the zillions of different bundles that are out there and can be installed in Eclipse. You only want to know very coarse-grained what are the capabilities and requirements of those. You might even only want to know about the capabilities, and the requirements and how to fulfill those requirements will be solved by the repository and the OSGi runtime. So, when you are faced when you are tasked to develop an application which might grow to this sort of complexity, where you have this plug-in capability and various people, even people you don't know about, can throw software in your system and make functionality available, then you need a solution that is, at least very similar to what OSGi provides in terms of modularity right now. In JBoss, we have developed the application server 7. Over the last half year or so, it has recently come out. We had the AS7 release, AS7 Lightning. It's called Lightning because it's lightning fast. When you bootstrap it up, on some machines it takes 300 milliseconds and the entire application server is up and running. And you can bootstrap it in your test case. You can, throw deployments at it at the scale of hundreds, and it will perform linearly. And so why is this possible? It is possible because OSGi AS7 has been designed with modularity in mind right from the start. It has also been designed for concurrent services right from the start, because application servers will run on multiple core systems most of the time. So what you really want to do is you want to have stuff happening concurrently all the time, right? So in JBoss, we have chosen not to use OSGi at the very bottom layer. We have chosen a different layer, which is called JBoss Modules. And JBoss Modules is different to OSGi, that it provides the very, very bare functionality which is also required by an OSGi runtime. So the thing to remember is AS7 does not run on OSGi, it runs on JBoss Modules, but JBoss Modules provides just the functionality that an OSGi framework needs from a modularity perspective. There's a comparison between the two. The most important one, OSGi, is the de facto standard. I mentioned that earlier. So when it comes to, when you want to write your application, you probably want to turn to a standard, like you turn to JPA, for example. Right. And there are several, features and functionalities available in OSGi which you will not have in modules. But it's good to know that it was possible to build OSGi on top of modules because modules provides the bare functionality. Same is true for services. JBoss has built-in service support, highly concurrent. Services can come and go anytime. Services are injected into each other. Services can create dependencies on other services. In OSGi, it's slightly different. Services are not injected. It's not an injection framework, possibly because OSGi has been around for quite some time. I think it's 10 years plus or so, before annotations came about in Java. In terms, services in OSGi support filtering, which MS services do not. So you can say in OSGi, I want service foo, location US. I've said this earlier. It needs to be secure, and any other type of metadata you have available for the service. Right, I I'd like to turn over to David, because he is the chair of the OSGi Enterprise Expert Group, and he is the guy who knows all about what's happening in the enterprise OSGi space. David, please.
Okay, if my microphone works. I've got a couple of slides here about what we're doing in the Enterprise Expert Group in the OSGi Alliance. And this slide shows what we have today in Enterprise OSGi. The EEG has done its first release a little over a year ago in early 2010. And currently we're working towards a second release of Enterprise OSGi. The initial release had a number of focal points, and one of them was to make existing Java EE technologies more suitable for use in an OSGi context. So this generally meant defining a number of OSGi services that represent the Java EE technology so that it can easily be used by an OSGi-based application. So the current set of enterprise specifications contains mappings for web apps, JTA, JDBC, JPA, JNDI, and JMX. And just to lift two of them out of this list, just to focus on the two of them, JDBC is an interesting example because JDBC has been difficult to get working in an OSGi context. Mainly because normal JDBC usage depends on things like class for name, which only works if you expose internal implementation classes of your JDBC driver. Now, there's people who manage to get it to work, but it's ugly and it's not the way we want people to do things in OSGi. So the OSGi JDBC spec solves that nicely by making the JDBC drivers available in the OSGi service registry so that a consumer, a user of the JDBC driver, can simply look them up from there over a standard interface, and there's no need for any implementation classes to leak out. JNDI is another interesting example. The JNDI spec defines two things. It defines how you can use JNDI within your OSGi bundle. So if you're in an app server, for instance in AS7, and you want to do a JNDI lookup as an OSGi bundle, you can, the JNDI spec describes how you can get hold of your JNDI initial context. So that's one side of the thing. The other side is pretty much the reverse. You might have a Java EE-based component, for instance, an EJB, and the EJB might want to invoke an OSGi service. Now, the JNDI spec actually describes how you can use JNDI to look up OSGi services. There's a special OSGi colon context, and you can use that to do OSGi service registry lookups outside of OSGi. So some of these mappings are supported in AS7. Thomas will talk a little bit more about that later. In addition to the Java EE mappings, enterprise specs also contain two entirely new specifications. One of them is the remote services set of specs. There's actually 3 specs that belong to that group, and they define how the OSGi service model can be used for distributed computing as well. Basically, it specifies or defines how you can add properties to your service registration to indicate whether a service is suitable for remoting. And if you have a compliant remote services implementation available in your framework, it will basically expose the service over the network. At the same time, OSGi service consumers can also be used to consume remote OSGi services using the same OSGi service model. Again, there's some extra properties involved, but the programming model is the same. So if you like OSGi services and you need to do some distributed computing, the remote services specifications are quite interesting. There's one other angle to remote services. the specifications themselves don't really describe the protocol or data binding that you need to use to distribute your services. But if you do use a standards-based protocol, like for instance web services, then you can use non-OSGi clients to invoke on your OSGi services. So, for instance, you could use a VB client to invoke your OSGi service if that service is exposed using web services, for instance. So, Blueprint is another specification that is part of the enterprise. It makes it's based on inspired by Spring, but it's not Spring itself. And it defines an injection, a component model for OSGi that makes using services much easier. So I'm going to quickly go to the next one. Thomas, next slide, please. And just a quick run through of the current set of specifications that we're looking at in the Enterprise Expert Group. We're planning to do the next enterprise release early next year, early in 2012. And the main theme around this release is applications and application models and provisioning. So I won't really go too much detail about all these specifications because we're running out of time. But just the first two of them, RFC 152 defines a number of application models for OSGi. Some concepts in OSGi, in RFC 152 are similar to what you might see in Java EE in the EAR file. So it allows you to define an archive which can contain multiple bundles, which can be deployed as in a single operation. So it will make life easier for deployers of applications. It also contains a few other things. For instance, it defines sharing models, whether that allow you to define whether your application is completely isolated or whether it's completely shared. You might want to share all your bundles with other bundles in other applications in the same framework, or maybe you don't. And RFC 152 allows you to specify the degree of sharing of your bundles. Another important one that we're currently working on is RFC 112, the bundle repository. This is similar to a Maven repository in a sense, except that it allows you to look up artifacts by specifying a query in terms of OSGi generic capabilities and requirements. So in Maven, if you want a resource from the repository, you need to specify its name and version, whereas with the OSGi bundle repository, you could say something like, I want a bundle that exports package X in version 2 with an Apache license or an LGPL license. And OSGi the OBR will basically respond to you and provide you with a number of candidates. The other RFCs, I will skip over them now because we need to keep some time for the demo. There has been an early access draft made available. If you're interested in the other RFCs or in RFP 133, you can look on the osgi.org website and look at the early access draft for more information. And back over to you, Thomas.
Thank you very much, David. So let's continue to talk about OSGi in AS7. So building on what I just said earlier, building on JBoss modules and building on JBoss MSC, we wrote an OSGi core framework right from scratch and made it available as subsystem in the application server. It is a fully compliant OSGi 4.2 core implementation. The TCK passes with 100%. We have not gone through the red tape of certifying that implementation mainly because the Alliance has already moved on to 4.3 and we would like to certify 4.3 when we have it. So what you do when you want to deploy or when you want to work with OSGi in AS7, you simply deploy it to the AS like you would with any other type of deployment. So we have, traditionally we always had hot deployments. So what you do, you drop your OSGi bundle in the deployments folder. There is also a management GWT application, GWT management application available. You can deploy it through there. Enterprise OSGi, and David mentioned it earlier, comes with a management interface itself, JMX. So you can manage your OSGi bundle deployments through the standard JMX interface. And the nice thing about that is, because it's part of the Enterprise OSGi specification, it's a standard. You can manage your OSGi bundles in a standard way through the JMX facade. There's also a command line interface available, which works with OSGi bundles. So there are a variety of how you work with OSGi, how you deploy OSGi bundles to the AS. I just mentioned this earlier, excuse me. We built on modules and MSCs. I won't talk about this again. OSGi comes, and I think I mentioned this also already, it comes with a resolver. And the task of the resolver is to consume all the capabilities and requirements from the various bundle deployments and compute in a non-trivial fashion, compute a wiring graph between those modules to come up with a possible consistent solution. So you have bundle A and B both requiring a package foo, but in different versions, right? So, and it's the task of the resolver to make sure that the dependencies are between the bundles are resolved correctly, so you don't get class cast exceptions when you pass a type from one bundle to another or from one service to another. So in JBoss OSGi, what we do, we examine the OSGi metadata, generate from that OSGi metadata a general set of capabilities and requirements, give those requirements to the OSGi resolver, let it do its work, the Apache Felix resolver. It comes back with the wiring result, and then we go back to the JBoss modules API to actually establish the dependencies between the modules. So what this allows us in AS7 is we can use OSGi services from Enterprise from Java EE components. So what you can do, you can write your servlet, or you can write your EGB3, or whatever component you have in AS7, and you can create a dependency to a particular OSGi bundle, and you call functionality you can invoke functionality from that OSGi bundle. So you can invoke services from your non-OSGi component model, and it works the other way around as well. So from OSGi, which is normally not possible in a standard, in a isolated OSGi runtime, you have full access to the other middleware services that AS7 provides, which are traditionally not available as OSGi bundles. So we integrate at the lowest possible layer, which is modules and services. Every bundle is a module, not every module is a bundle. Enterprise OSGi in AS7, so out of the box, you of course have the OSGi core API available and the compendium API. The compendium is a very large collection of standard services that OSGi comes with. There is services for configuration, for eventing, for HTTP service, for wiring, and for XML parsing, and for a lot of stuff that you would normally want to use is available from the compendium. We have JMX, JNDI, JTA, Web App, and Blueprint. We also have a web console available, which you will see in a minute. The next steps is we would like to provide an OSGi 4.3 implementation and provide more functionality through the OSGi layer. So a possible candidate is CDI and possibly, JPA Hibernate. Right, and now I'll turn over to the demo. Let me try to share my desktop. So in this demonstration, I'd like to show you how to invoke an OSGi service from an EGB3 stateless session bean, and also how to invoke an OSGi service from a web application, so a servlet. Right here in my terminal, I have an installation of AS7, and I boot it up real quick. I have to do this one-handed, like this. Right, here we see that AS7 bootstraps on this machine in just 4 seconds, a little over 4 seconds. This is a really slow machine, a Macintosh, a very old one from my wife. And now let's go to the other terminal where I have a build from several OSGi bundles. Which I built right now. Okay, that worked. So what you see here is an API bundle which provides just the interface of a payment service we are going to connect to. This is the implementation of the payment service I'm going to show you in a minute. And these are the two clients, an EGB3 client and a web app client. Let's look at the code real quick. It is here. Here you see the payment service. It's really trivial interface. It has a process method, and it takes an account string and a float for the amount that is to be deducted from that account. As I said earlier in the presentation, every bundle may have a bundle activator, which gets called when the bundle starts. These are the lifecycle methods, start and stop. And in the start of the OSGi service implementation, I create an instance of the service, which you see here, and register the service with the OSGi runtime. So this will happen when the implementation bundle gets deployed. On the stateless session bean side, I have a post-construct method. So this gets called when the bean gets constructed, and in post-construct, I set up a service tracker, which tracks the payment service. So the idea is that the stateless session bean does not do the service lookup. Instead, the OSGi runtime provides the service to the stateless session bean whenever a payment service becomes available. So in this particular implementation here, what will happen is every time a payment service enters the OSGi runtime, this method gets called and it will override the service that is being used by the stateless session bean. So in this demo, it doesn't matter because I know there is only one payment service provider, but this is something you will have to watch out for, possibly provide additional metadata, which in this case is now additional metadata for what type of payment services you are interested, or you have more sophisticated logic in here where you examine the properties of the service so you make educated decision what service you're going to use in this stateless session. Right, so let's deploy these bundles. So these are two bundles I'm going to deploy, an EGB3 jar and a web application bar file. So do it like this. This simply copies over the files to the AS7 instance, and here they're being picked up. And as I said earlier, the OSGi subsystem is started lazily. So as soon as the first deployment comes in, the OSGi subsystem gets bootstrapped. So this happens at 56 roughly, and the OSGi subsystem then installs a number of infrastructure bundles, bundles that provide the the functionality that we want to have available in JBoss AS. So we have, for example, logging, we have configuration admin, we have JMX support, we have the web console, which we will look in a minute, and various other bits. The bundles get installed, and afterwards they get started. So the OSGi framework started at just after 4 seconds. So this is a comparatively long time. So this is why we choose to activate it lazily. But this time cost will only appear once. So then we install our bundles on the demo, the API bundle, the implementation bundle, and the bundles get started. As you can see here, the API bundle and the application bundle. Additionally, we deploy the EGB3 jar. Here are the JNDI bindings from the stateless session bean, and also down here we have the web application deployed, and here's the servlet context the web application is listening at. So now let's go to the OSGi web console, which is here. Right. So in the web console, you see the number of bundles that are being installed in the runtime. We also see the 2 demo bundles. Let's look at one of them, the API bundle. Here you see the metadata associated with that bundle, the bundle symbolic name, which every bundle has, its version. And important for this demonstration is that this bundle only exports this single package here, right? It imports packages from the OSGi framework, and that's it. Yeah. Here's additional metadata, not very interesting. Let's go back. Let's look at the implementation real quick, and you see here the implementation bundle imports that particular package, and it also says from where, from which bundle it imports it. And also important to note is that the implementation doesn't export anything. So even though in the implementation bundle there are public packages, those public packages won't be accessible from outside, from anywhere in the system. All right. So now I start a new tab and invoke the servlet. And you see here, it's calling the OSGi payment service, and I charged $100 on the account through. And the same is possible to go via the simple stateless session. So the servlet calls into EGB3, as you would normally with a Java EE application. Servlet is the presentation layer, and EGB3 might be your persistence layer or where your logic is. And in this case, the EGB layer is, again, an intermediary layer, and the service is available from OSGi. So this payment service might be available from a third-party bundle that you just bought. Right, so OSGi supports bundle updates. We try this. We go back to the code and go back to the implementation and change the implementation a little bit in a trivial way. Save the file. Go to the console. Change to the implementation directory. Do a build. Right, that's a success. So now I could copy over the new jar to the deployments directory, but I'm not going to do that. Instead, I'm going to go back to the web console and try to do the update via the web console. So I browse to the directory where this lives, which is here, I think. Yes, and I do install or update. Right, and let's go back to the console and see what happens. And you see here in the console, the bundle stopped, and adding services was called from the service tracker. The bundle was started, and the bundle was updated. And this is an asynchronous process. Updating an OSGi bundle is an asynchronous process. So if I now go back to my application and I call simple payment again, I see payment service charged $100 to account through XXX. So what you've seen here is that without taking the OSGi runtime down, I made changes to the implementation of the service. I updated the service on the fly without taking the clients down. The clients got the new implementation of the service provided via the service tracker, and the next invocation from the client to the service uses the now fixed implementation of that service. And I think this is all I wanted to show you. It only showed, well, it showed the ability to call an OSGi service from a Java EE component, but in AS7, the opposite is possible too. So from an OSGi bundle or from an OSGi service, there are means to call into a Java EE component as well. So you have the full functionality, the full middleware functionality that is otherwise available in AS7. You have that available from your OSGi services as well. Right. So we have a little bit more time, 5 minutes, and I would like to get to the Q&A session, and I'm happy to answer. David and I am happy to answer your questions if you have any. Thanks.
Thank you very much, Thomas. The first question always at the top of the list, and we've seen it in this session as well, is why didn't you guys use Equinox or Felix or something like that?
Right, and the reason for that is, the more general flavor of this question is, why should I use JBoss OSGi, and why should I use, or can I not use Felix or Equinox? And the answer to this question is that Felix and Equinox, they are both very mature projects, and they are great, for that respect, and they provide a pure OSGi environment. But when designing AS7, we had very, very strong, measures given to us from marketing. We said, we want to bootstrap in a fraction of time of Glassfish. We want to be able to, take hundreds of deployments. We want to scale linearly. There should be 10,000 services available in the system, coming and going, and we did a lot of micro benchmarks. And what has come out of this is that building an application server on top of an OSGi framework, which many of the other application server vendors have done. I think, Glassfish and IBM has built WebSphere on top of OSGi and so on. It works, it has been shown that it is possible to do so, but our micro benchmarks have also shown that it's not possible to use OSGi as the foundation technology and provide the user experience that we actually were aiming for with AS7. So we decided to take the ideas of OSGi, to address modularity and dynamic services, because this is what we also need in AS7, but we do it very direct, very fast, very, simple, and, direct, I already said, to provide the user experience that we actually wanted.
And another question that I've seen multiple times here is related to how are there going to be future integrations or more detailed integration between Java EE technologies and OSGi? For example, making every EJB jar or every CDI jar a bundle, kind of out of the box, without having to use Service Tracker and having to use some of the other things that they saw here. And also related to that, will the integration not only be cleaner in the future, but will OSGi be part of the Java EE specification in some form or fashion?
I can't answer the last question. It's always very difficult to make prediction, especially if they concern the future. But I answer the first one. Will it be possible that every EJB jar is an OSGi bundle? Well, yes and no. What we do currently is every EJB every EGB jar is a JBoss module, at the foundation level. And every OSGi bundle is also a JBoss module. And what you can do today is that you can register an EGB jar with the OSGi layer. So what does that actually mean, registering an EGB jar with the OSGi layer? So what you need to do with an EGB jar is when you give it to the OSGi layer, you need to say what capabilities and what requirements that EGB jar has. So an EGB3 jar does traditionally not have that type of metadata information. So it's a jar file, So how do you figure out what packages from that jar file are actually part of the contract and which are not, And so this is a very difficult question to answer, which cannot be automated, in my humble opinion. So the approach that we have taken is that you can, any deployment in AS7, you can put side by side with it, you can put your metadata description, and you say, this particular jar provides as capabilities these packages, for example, right? So, and those get interpreted as general capabilities by the OSGi layer, and then later, when another OSGi bundle comes in or another type of deployment, the OSGi layer knows about those capabilities and can wire to it. So the answer in a nutshell is I don't think it can be automated, because it needs some human thought to, right from the beginning, what are my capabilities and requirements. And it would be very stupid, to sort of walk the package tree and export every package that you find, because it would defeat the idea of modularity. Like making everything public that you can see is not what you want. Right, and also it would introduce an additional cost. So the wiring, the resolver has to do its work. When every jar is known to the resolver, it has to be considered in a non-trivial computation and to compute the wiring result. So the net result would be that the application server would be a lot slower. So our answer is, design for modularity, make a conscious decision where to use OSGi bundles and where not, and apply OSGi terminology where it's needed, and it's all about, the choice. You make a conscious decision what technology you want to use for your particular application. Maybe I can turn the answer to the second question over to David. Will OSGi be part of Java EE?
Okay, well, like you said, Thomas, I think it'd be hard to look in the future, but I don't expect OSGi to become part of the JCP specifications. However, in the Enterprise Expert Group, we have been and we are continuing to work on integrating Java EE and OSGi. There are some efforts currently ongoing, and we have done some work in the past. So the integration will become better in the future. That's definitely the case. I'm not sure whether that's going to be done in the JTP. I think it will be done in the OSGi Alliance.
There's also a different angle to this question. This is, will modularity be addressed at some, other level of specification? And I think the answer to this is yes. Java 8 addresses Java modularity in one way or another, and so we are part of this design and discussion, and so OSGi will probably not go. Will not become available at the JVM, at the language level, at the JVM level, like you, for example, have the HTTP server now. But there will be functionality. There will be modular functionality available at language level at Java 8. At least that's the plan. Probably not full OSGi functionality, but it will address modularity in some way or another. service is not, as far as I know.
All right. Well, that is all the time we have today for questions. There are a few more questions, and you guys can, David's done a nice job answering several of them as they came in the Q&A panel. But Thomas and David, thank you very much for your time today.
Thank you.
Pleasure, Burr.
And we have the links slide up here so you guys can see where JBoss.org, JBoss AS, JBoss AS OSGi. Feel free to go check those out. Make sure to download AS7 and give it a try. And we sent the GitHub URL that you guys asked for out to the Q&A panel also. If you're interested in the demo code that you saw from Thomas earlier, give that a look. So excellent stuff. Thank you guys very much.